with Nathan, and then we can go down from
Um, so this is like it's really popular to pick on me recently. I don't know. I don't actually have a lot of thoughts about this. I think I missed a lot of meetings over the last month, and I think that maybe some of the background, particularly with P2P, um, might have been useful, but I didn't pick up. Like, I mean, overall, the amount I've not quite gone through reading the whole spec yet, but it seems fine. It does actually make me want to read more about distributed hash tables. I kind of had it in my head that there was just kind of one class of DHT, but it sounds like there's actually quite a number of different implementations of that, and so now I'm kind of a little more interested in that. But yeah, I actually I don't think I really have too much productive to say. It seems fine. I don't know, Venkat, maybe you can add more.
Yeah, I do remember. Uh, I think we had a session on libp2p, and yeah, Cademelia sounds familiar. I think we might have been discussing it in the IPFS track because I think IPFS uses something similar. Yeah, so lots of systems apparently use some version of this thing derived from this Cademelia model. And I was just talking to ChatGPT about it. And so far, the main thing I've gotten out of it is it uses the XR metric for distance. So every node and key is assigned like uh, it's basically a long binary string, right? And the distance between any two nodes or keys is just the XR between them. So ChatGPT claims that this is a very elegant solution for various reasons. One of them being you can independently compute a map over the network centered on yourself that looks kind of the same as everybody else's. So it's consistent. So the distance metric is symmetric, right? So if I XOR my key with yours and you do the same, we'll both get the same answer. So XOR is a pairwise symmetric, so that works. And it creates like a distance, abstract distance metric over the graph that has nothing to do with physical distance. So if you have like two computers sitting on the same rack, um, they might be on opposite sides of the planet as far as the XR distance is concerned. And if you're like trying to like do a multi-hop discovery of something, it could be that you end up like hopping around the planet multiple times to, find a node. So that seems to be, yeah, it's physically very inefficient, but on the internet, who cares? Multiple hops is just a couple of more milliseconds or whatever. What I don't truly get is how you bootstrap an elegant handshake and discovery problem or solution out of it. And I think backing up a little, I'm also just fundamentally confused about the what that document calls the Achilles heel. Like if there is no central rendezvous server, like centraldirectory.com type place where you can go and look up anything, how do you even know where to get started? All right, so you downloaded some software and you set yourself up as a node on some network. What next? Where do you even start to find any peer on the network? So I actually didn't quite get how that's solved. So if anybody understood that part of the problem, um, yeah, that would be helpful if you can explain that. Anuraj?
Yeah, the first time I started looking into these peer-to-peer protocols, I was also a little bit confused how anybody bootstrapped it. But it seems like, at least initially in Discovery V4, there was like hard-coded boot nodes which you could query, and I think in Discovery V5, I think there is some sort of bigger a DNS node list that you could query. So yeah, it's kind of you are to bootstrap. You are kind of querying some sort of maintained lists of peers. So I think at least one of the Go implementations I saw, I think it was like querying the Ethereum Foundation run node. So right now I think it's like DNS based, uh, and it assumes that DNS would already be always be available. So that is what the one of the documents said. Uh, but I was yeah, and then the other thing was like lib. So disk dev P2P is used in on the execution layer, and lib P2P is used on the consensus layer, and there is some history regarding it. So I think when they were trying to write the protocol, lib P2P was not mature or ready enough, and so they wrote their own custom protocol for the nodes. And when lib P2P was like mature enough, and when the merge happened, so I think the consensus layer moved on to lib P2P, and I think the lecture also said that there has been no need to update uh, the execution layer protocol to lib P2P. But yeah, I was like also trying to think about like in terms of robotics, like if there like so there are certain distributed communication protocols in robotics called like DDS or Xeno, but like most of them assume it's not like a dark forest kind of environment. So it's like there is always some sort of trust between the nodes. So it's and but these protocols assume that you actually do not trust anybody. So that was an interesting comparison between the two different worlds. With that, I'll pass on to Ben.
Yeah, yeah, I did. I looked at the stuff. I linked my Claude quick discussion, and basically what it seems is that Dev P2P is just sort of lib P2P, but focused and specialized. Basically, lib P2P is designed to be really modular and be able to do lots of different things, lots of different choices. It's all pretty abstract. Like it ships with like some base level stuff that you can use, but you can use other things. You could use Tor as like the transport layer if you want. You can use various things. Dev P2P, and it looks like what happened was they built Dev P2P sort of at the beginning, um, probably over a decade now when Ethereum was first being launched. And so they just made these choices and sort of said, all right, we'll choose this, this, and this instead of making something that's modular that can ever be changed. That's why in the long run they are trying to slowly migrate to something more like a lib P2P based. And this happens with like a project. You start off and they probably didn't know too much about peer-to-peer networking when they started, and then they said, all right, we need these things, let's implement them, and sort of crank that out, and then realize they had something that is not as good or maintainable or as forward looking as something like libp2p, which was designed to be modular and to be those things, and they were like, oh, well, if now we're working with something that's in hindsight, if we could go back in time and just know what we know now, we wouldn't have done that. But that's always how it works. If you could do that, you'd be not having to deal with stuff like this. So yeah, now it's if they can slowly move to something like libp2p, they will, but it'll take a very long time if it happens at all, just because trying to change a mature system, pain in the ass, and this is the case where costs, issues, bugs are high, and it doesn't actually matter that much that old nodes use dev P2P instead of lib P2P. It's not something that's user facing or actually as long as dev P2P works, it doesn't matter to the network. So it's like something that cleanup maintenance stuff that might need to be done at some point in the future, but that isn't really important now. Um, yeah, and Venkat asked sort of like the looming elephant sword question over the whole thing is wait, if you have a peer-to-peer network and you have no hard-coded nodes, how do you find peers when you first start up? And the real answer is you don't. You have a list of hard-coded peers and you hope they exist. Like, you probably can also, like, go to a config file if something happened to those peers, and somehow you could go to like some kind of chat or like Google, or you could find other peers and just plug them in directly. But basically, that bootstrapping problem is really hard, from sort of like a technical perspective, because now, I mean, I've tried to think of like ways, like, is there a way to scan? Like, could you scan, like, to try to find other nodes on startup? And even if you try to do various things, it doesn't really work that way. It would take way too long. Um, so you're basically stuck with, if you want it to like actually be snappy and start syncing in the first hour or so, you're gonna need to be like, all right, tell me what these seed nodes are. And it's one of those things where it works really well until it doesn't. So everyone sort of ships with it, and just kind of sweeps it under the rug, doesn't talk about it. It would be interesting to find like a system where that you didn't have to rely on some hard-coded seed nodes or things like that. It's definitely a hard problem though, just because you need some kind of way to find each other in you can't scan every IP address in the world and ask if they're in an Ethereum node. I mean, you could, but it would take too long and be too much, bandwidth and stuff. Make you look like you're some kind of like scanner or something. Um, but yeah, it's yeah, I think that's pretty much it. I believe now we're back to Nathan, so it's if you want to, my floor is open if anyone wants to say anything.
I have a quick thought I wanted to share. So I was thinking more about, like, all right, forget Ethereum and these specific solutions. How would you actually conceptually solve the problem at all? And I was thinking of the Sherlock Holmes story, The Final Problem, where Holmes has his, like, fight with Moriarty and supposedly and seemingly dies, right? If you've read that story, you'll remember that early on in the story, when Holmes is trying to run away from Moriarty, he tells Watson to come meet him at some railway station or something, and he says, when you come down from the apartment, take a cab to the station, but don't take the first cab or the second cab. Flag down the third cab that comes by and write that to the station, because he thinks Moriarty will follow Watson to the station. And yeah, the third cab, it turns out, is driven by Mycroft, Sherlock's brother. So he's arranged. So there's a discovery problem, right? You want to discover in the network of identical looking London cabs which ones have been captured by the malicious actor Moriarty and which ones are honest nodes, right? So he's basically, I guess this is a kind of nonce, right? He's injected a random nonce into the discovery protocol and says, let the first n nodes go by. The first n nodes that you see, let it go by, and then the n plus 1th node get into it. And in this case, he's injected a trusted node into the n plus 1th place that's sitting around, but you don't need that. You could just say something like, all right, like, take the problem of finding a trusted coffee shop that won't be like terrible in a completely new city and there's no Starbucks there. Maybe one way you can do that is just wander the streets and look around for the same branding showing up everywhere in a coffee shop, right? In South America, Juan Valdez Cafe is common in Colombia. And you've never seen this coffee shop network before, but it keeps popping up on every other street. And you notice that it's selling coffee. So just to make sure you get your cup of coffee in a trusted version in case half of them are taken over by a criminal network or something, you like walk past 3 or 4 and go into the like nth one. That way you'll avoid problems like, maybe it's a criminally controlled city that has taken over all the coffee shops near tourist entry points like railway stations and airports, and therefore you should not go there. This is actually true of like money changers, right? They tell you don't change your money at or near the airport. So I think there may be conceptually good solutions to the discovery bootstrapping problem if it's a dense enough network in the space where you're starting to look. And in physical space, it's kind of obvious what that means. But in digital space, it's not obvious. But one way you can think of that is if you want to find, like, say, a trusted blockchain network that accepts payments and, like, hill climb your way to, like, bringing a node, what you can do is wander a lot of random websites, see what kinds of, like, wallet support they offer, and then from those wallets back out what blockchains are available, and I don't know, somehow climb your way to the randomly picked place to find a node to trust. From it, you go enter the network. And you can do this backing up into the wherever you downloaded the software from as well. Of course, I mean, software downloads will be signed or whatever, but you still need to, like, get your software bundled from a trusted place. So that's actually a separate discovery problem too. You kind of have to, like, randomly pick from the sources available. I don't know if this is meaningful, but it feels like there are approaches here.
It sorry. Um, it I think a little bit of what you're describing is kind of akin to um, tofu, which gets used a lot of places. So trust on first use. You just kind of you say, well, the chance of there are adversaries out there, but the chance that any one connection I make is going to be to an adversary is very small. So probably the first connection I try is going to be fine, and I can trust that. And then the question just becomes, how do I do that? And I can look for, what you were saying, like what's common, or there's lots of different ways to do that. Or there's an advertised directory, or people are advertising these things through a side channel, like websites or wallets or something. And that kind of works as long as, like, the adversary isn't gunning for you in particular. So sort of distributed, like the sort of miasma of cybercrime, that's probably a pretty good strategy. But it kind of falls apart if once you start going against state level actors. I do think it is notable that it does seem to be, whenever somebody tries to replace DNS or certificate authorities for a distributed system, they almost always wind up having some bootstrap variation of trust on first use. Um, it does seem to be the fallback mechanism. So I think it's a common solution, and I do think it kind of harkens back, Venkat, to something that you were writing. I think it was sometime last year, where you were talking about different kinds of scaling in your newsletter, and how you had a very, like, a lot of the scaling that you see in cryptography, and I think in blockchain, is very, very adversarial. You can't trust anyone. And so that makes scaling very, very hard. And it makes bootstrapping very, very hard if you're like, I have to be suspicious for everyone. But if you operate in a world where you're like, well, most people are fine, so suddenly scale, it becomes, you have a lot more flywheels to scaling. And tofu is like, so you would never really suggest it for in a highly adversarial world where you're like, is that really Venkat? Is that really Ben? How do I know that you are the person you say you are? But in our normal lives, you introduce yourself, and I assume initially you are who you say you are, because generally speaking, that is a safe assumption. The number of bad actors I will meet in my life is much smaller than the number of good actors. And so that lets me start scaling and building networks. And as I build that network, then, once I have that first couple trusted connections, I can then start, like, Ben and Venkat introduced me to Jenna, and I'm like, okay, well, you two know, and I've trusted you two, so I can probably trust Jenna, and I can build that way. And so tofu sort of, it doesn't eliminate the first bootstrap problem, but it does make it easier. And I think it also only works in a world where you assume that there are more good actors than bad actors, which is probably reality, but is not how a lot of crypto systems are designed.
There seems to be a
So one thing I'd
yeah.
want to point out is that sort of an issue that the first issue with the bootstrap, it's not actually, the issue isn't finding bad nodes. It's finding any nodes at all. So like imagine you're starting up your Ethereum node or whatever, and you want to connect to peers. I mean, yes, if you only ever connect to bad peers who show you a sort of like a limited version of the network or a false version of the network, you could have trouble. That's what's called an eclipse attack. But actually, the system is generally more robust than you're sounding. If you find one single good peer, because of the way the system is constructed, with economic finality or so on, unless the attackers have paid very, very high costs, at the end of the day, you'll see that, oh, this network I was on was incorrect or incomplete, and I'll switch to the new one. So you really just need to find one peer that's honest. It's a one of n problem, not a like a 50% or something like that. Um, the downside is it's hard to find peers at all. So if you're just starting up an ETH node and you don't know where to look, like you can randomly query IP addresses or whatever and ask, hey, are you an ETH node? But there aren't that many ETH nodes compared to like the full space for the IP system. So you're suddenly in a, it's less of a problem of like you being surrounded by strangers which may or may not be trustworthy, but it's more of a problem of you're surrounded by people but you're in part of a club, and you need some way to find someone who is also part or says there's part of the same club, whereas most people, if you ask them, they're just gonna go, what are you talking about? So it's like it's trying to find the subset of no of IP addresses or identifiers who are actually running your protocol. um and then once you have that, you can try to reason about are they malicious or not. Anyway, I think Anuraj wanted to say something.
Any more thoughts? Then we will look into it. Thanks, guys.
Didn't quite make that out. You're really muffled.
Can you hear me now? Yeah, I thought I was just asking if there are no more thoughts. We can meet in 2 weeks. I'm still not audible.
All right. See you guys next week.
Okay.